Welcome to Future Talk, the show that examines the global impact of technology, both for good and for bad. Our society is heavily dependent on technology, but maintaining that technology requires people who are very well educated, especially in math and science. But our methods of teaching math have hardly changed in the past several centuries, but that may be about to change. I have three guests to discuss some of the new approaches to teaching mathematics. Peter Fries is president and CEO of the Tech Museum of Innovation, which is the underwriter for this program, and he's also an experienced clockmaker. Keith Devlin is a mathematician and executive director of Stanford University's H-Star Institute, which studies the relationship between people and technology. He won the 2007 Carl Sagan Award for science outreach activities and is known to NPR listeners as the Math Guy on Weekend Edition. He's written 28 books and is now working on a project to use video game technology to help middle school students learn mathematics. Salman Khan is the founder of the Khan Academy, which is a one-man internet venture that aims to provide free, world-class education to anyone, anywhere in the world. His 1,400-plus videos on YouTube have garnered over 16 million views and have received glowing testimonials from all over the world. Khan Academy is now the most popular open education K-12 education resource on the internet, and it's recently been profiled on CNN, NPR, and the PBS NewsHour. Salman received the 2009 Microsoft Education Award at the Tech Museum in San Jose for using technology to benefit humanity. I'd like to welcome all of you to the program tonight. And Peter, let me start with you. What is the Tech Museum doing to advance new math education?
First of all, if you go to a museum, especially to a science museum like the Tech Museum is, then there is math everywhere. In every object you have math somehow. What is the difference to the normal school industry? When you come to a museum, you have to explore the space for yourself. You have to be very active, and it's up to you what you learn. But parallel to this, the Tech Museum offers some very interesting programs. One especially is where we bring teachers, kids, and parents together in one classroom. Because as we always know, kids go home and say, I have a problem to understand, and you have to have education from your parents. So sometimes parents don't even have learned themselves what's now going on at school, and therefore building this triangle between teacher, kids, and parents is a very, very helpful thing, and that happens at the Tech Museum.
So is this sort of an experimental prototype where you're experimenting with different ways of learning the role of the parent, the role of the teacher, the role of the student himself?
Exactly. The Tech Museum would not be in Silicon Valley if we would not do these kind of experiments all the time. So we're looking for new ways of how to bring these difficult subjects closer to the people, that people really can make use of what they've learned in the museum and becoming a global citizen, a well-informed citizen about science, that problems like we have them right now down in Florida cannot happen or going to be treated in a much different way.
So does this approach, does it get outside the museum, so where, for example, school districts are watching your experiments and what you're doing and seeing how they could apply it to their own teaching?
Yeah, we are working together with teachers, we are working together with the kids, and we let them participate in building the museum. For instance, we have a program right now where kids are in front of teachers getting educated on a science subject for about 20 minutes, and then they have to repeat what they've learned in front of a camera. And these videos are really, really good. They show us what people can learn in 20 minutes and how they explain what they've learned to the audience. And those videos finally end up in the museum itself in front of the science experiment. So the video basically with the kid on the video explains the science experiment. There are no labels anymore.
Well, I gather that there is a need to upgrade teaching because it hasn't really changed much lately and the needs have changed. So Keith, how long has it been since there has been a major upgrade to the way mathematics is taught?
Well, The three images that I brought along to show to the audience are from a book that was written in 1202. It's by Leonardo of Pisa. It was written in Latin. It's called Liber Abaci. It means the book of calculation.
Can we see those pictures? I think we have those images. Let's go ahead and show those pictures.
Okay, so this book appears in 1202. It was the first arithmetic book that ever appeared in Western Europe. It looks very little different from an arithmetic book today. It's that the language has changed. We don't write our books in Latin anymore. They've got a little bit thinner. That was about 600 pages. But essentially, arithmetic teaching hasn't changed in the West in 800 years.
Now, one might say, if a system has worked for 800 years, why does it need to change
well,
now?
I think many people in our audience will say that it hasn't worked very well. We've been using it, we've used textbooks because for 800 years, that was the only way we could capture mathematical knowledge on any kind of device that we could distribute to a large number of people. It had to be text. But mathematics isn't about facts. Mathematics is a way of thinking about the world, problems in the world. It's something you do. Now, what's the best way to learn something you do? You do it. If you want to learn to play chess, you can learn the rules from a book, but you won't learn to play chess until you play the game. If you want to learn to play tennis, the book will tell you something, but you've got to go out and play tennis. You can't always learn by going out and doing the real thing. For example, if you want to learn how to fly an airplane, you learn in a simulator. If you want to learn how to be a brain surgeon, you will be trained in a simulator. The US Army uses simulators to train troops before they go to Iraq.
Now, how does this apply to mathematics?
So, mathematics learning is more like learning to be a soldier because there's a danger element that people will get scared. The best way to learn mathematics is either in a real-world environment where you're using that mathematics, and those are difficult to come across, especially with classes full of students, or you learn it in a simulator, and the modern word for a simulator is a video game. That's why I've spent the last 5 years looking at how you can use video games, massively multiplayer online games, to provide environments in which students can learn mathematics in a real environment.
When you talk about teaching people how to think mathematically, what does that look like? How does a person who thinks mathematically differ from a person who does not think mathematically?
In almost every respect. For example, we don't get nervous when numbers are bandied around. We know what the numbers mean. We know that if the prices go up 10% this week and come down 10% next week, they don't go back to where they were. We just have this sense of what the numbers mean. And what video games are ideal for, you can use them for doing all kinds of mathematics, but what they're ideal for is getting people to that familiarity with numbers and quantities that are really part and parcel of being a citizen in the 21st century in a country like the United States.
So we're getting away from the traditional rote learning where you just memorize everything whether you really understand it or not.
Mathematics, today more than at any time in history, it's important to be able to think like a mathematician. You actually no longer need to do a lot of the detailed mathematics. We have machines like this device like that Peter's got next to me that will do mathematics for us. We have computers to do that. We have checkout machines at the supermarket. Doing the calculations is not as important as it was when I was a child, but thinking mathematically, that's the coin of the realm in the 21st century.
Well, I think the students of the future will be very happy to learn that they'll be able to spend their math class playing video games.
I would hope they would, because learning math should be fun, and by golly, we can make it fun.
Now, you're working on this project. Where is this project? Is this game ready to roll off the shelves?
Absolutely no. We started off 5 years ago thinking that this might cost $30, $40, $50 million. My current estimate is this is a $500 million operation at least. I'm now calling this the Apollo program in mathematics education. It's the educational equivalent of putting some person on the moon. We want to put some person into a mathematical mind and keep them alive, if you want. So it's got to be a big national program. This is not something that even a large video game company can do. This has to be a national initiative, because that's the only way to do something on this scale.
Now, that's very interesting, because you're talking about a $500 million expenditure to build this video program. Now, Sal, you have created Khan Academy, which essentially provides free education, which costs next to nothing to produce, and you've had 16 million viewers already. What is Khan Academy actually, and how does it really work?
Yeah, so most people know it as this library of 1,400 videos on YouTube, and as you mentioned, it's got 16 million views. It's now the most viewed open education library, more than, especially on YouTube, more than MIT and Stanford, and all of the videos have been made by me. I'm the faculty of the Khan Academy, and the goal is to I'm going to keep making videos, but we're supplementing that with a software piece and eventually build a community around the site so that students can start teaching each other. And the goal is really to be a free virtual school for the world, a place where anyone can go to the site and learn at their own pace, get feedback, get data on what they're doing, and start at any point and get to any point. If you go to the site right now, you'll see there's a video literally on 1 + 1 = 2. That's the very first arithmetic video. And the videos, 1,400 videos is a lot of material. It goes all the way up to, the last calculus video I did was a surface integral, and you can go into differential equations and physics, and there's even stuff on the financial crisis and all of that. So the goal is to start at a basic level and go as far as you need to go.
Now, before we discuss Khan Academy further, we're actually going to view some excerpts from some of your videos. So what are we going to see in these excerpts?
Yeah, the one thing that I think stands out to a lot of people is that the form factor for the Khan Academy is fairly different than what you would expect as online video. You're not going to see the instructor. You're not going to see someone at a whiteboard kind of teaching away from you. All you see is a black background, some writing in different colors that look nice, and a voice. And I like to end the voice is this voice. And I like to think that it's more of an experience of me sitting next to you and we're doing a tutoring session, or me being in your head, and more of an intimate kind of one-on-one tutoring, informal type of framework, I think.
Okay, so we're going to go ahead and roll that video. Let's take a look at Sal's video, and then we'll come back and discuss it further. Let's roll that tape.
So notice, we interpreted the statement in two different ways. This was just straight left to right, doing the addition, then the multiplication. This way, we did the multiplication first, then the addition. We got two different answers, and that's just not cool in mathematics. If this was part of some effort to send something to the moon because two people interpreted it a different way, or one computer interpreted one way and another computer interpreted another way, the satellite might go to Mars. So this is just completely unacceptable, and that's why we have to have an agreed upon order of operations, an agreed upon way to interpret this statement. So the agreed upon order of operations is to do parentheses first. Let me write it over here. Parentheses first. Then do exponents. If you don't know what exponents are, don't worry about it right now. Exponents. And in this video, we're not going to have any exponents in our examples, so you don't really have to worry about them for this video. Then you do multiplication. I'll just write mult, short for multiplication. Then you do multiplication and division next. They kind of have the same level of priority. And then finally, you do addition and subtraction. Finally, you do addition and subtraction. A neuron could be, a reasonably normal size cell, although there is a huge range. But the axons can be quite long. They could be short. Sometimes in the brain you might have very small axons, but you might have axons that go down the spinal column, or that go along one of your limbs, or if we're talking about a dinosaur, go along one of a dinosaur's limbs. So the axon can actually stretch several feet. Not all neurons' axons are several feet, but they could be. And this is really where a lot of the distance of the signal gets traveled. So let me draw the axon. So the axon will look something like this. And at the end, it ends at the axon terminal, where it can connect to other dendrites, or maybe to other types of tissue or muscle, if the point of this neuron is to tell a muscle to do something. So let's say I go to the local grocery store. Let me draw that in orange. So let's say I go to some grocery store over here. I'll say G for grocery, and I buy $100 worth of groceries, and I want to pay with my newly issued credit card. Let me write this down. This is the issuer. This is the issuing bank. I go to the grocery store. I say, hey, I'd like to pay with a credit card. The grocery store, if they accept credit cards, they need to have some relationship with another bank someplace on this Visa network in order for them to accept a Visa card. So let's say that they have a relationship with Bank B over here. This would be the merchant bank, or we could say the retailer's bank. Or it's often in credit card lingo called the acquiring bank, or the acquirer. And you might wonder, why is it called the acquirer? It's called the acquirer because this is the player that goes out and goes to each of the merchants and says, hey, right now you only accept cash or you only accept American Express. Wouldn't it be great if you also accepted Visa or MasterCard? That way you'll have a more appeal to more customers, and every time, and it'll be more convenient for your customers, and every time a transaction happens, we'll just take a little bit of a cut of that transaction. And so they go out and acquire different retailers.
I guess that was some sample videos from Khan Academy. And I like your style of delivery because I don't think you're going to lose anyone. It's kind of folksy. You're not rushing through it. But it looks like the videos are very simple to produce. It looks like they cost next to nothing to create. Is there anything preventing other people from also jumping into this field and creating their own similar videos?
No, and I hope they do it. It literally, to produce these videos, I think some of the people at home could start doing it tonight. You just need a little pen tablet. You can get it the local electronics store for under $100. I use Screen Capture. You can get shareware versions, and I'm just using an art program. I started doing Microsoft Paint. I've now used other slightly more fancy shareware pieces of programming. But it's very simple, very easy. I started doing it just because I was remotely tutoring my cousins in New Orleans, and when I was doing that, we just had a shared whiteboard, and we didn't see each other, and it seemed to work. So I figured, hey, why not do it the same thing? And then I wouldn't have to get a camera crew and all of that on.
Yeah. Now, how are the videos used? Is this something that a person just watches at home alone, or can this be brought into a classroom situation?
When I started, I envisioned it being some type of a supplemental material for students so that when they're home, if they need to remediate, fill in gaps in their knowledge, they can just dive in and get a 10-minute nugget that fills in a basic building block, and they can pause and repeat it as much as they want. But I've gotten a lot of feedback. It's starting to be used in the classroom, and really it's an organic process, and it makes a lot of sense. If you think about it right now, I've gotten an email from a teacher in London that said, we've flipped the model. We are now, instead of doing lecture in the classroom and homework at home, I now assign Khan Academy videos at home where the students can watch it at their own pace, at their own time, pause and repeat, fill in their gaps in their knowledge. And then when you come to the classroom, then you do your homework. And then you get the benefit of the teacher being around. The teacher can observe what students are doing, and the students can help each other. So you're actually taking advantage of the social aspects of a classroom to actually teach each other. So it can be used either. It could be used for a homeschooler. I've gotten letters from parents who, one, they use it for their kids, but they also use it to stay ahead of their kids so that they can teach them one step ahead. So it's really I'm learning of new applications for it every day.
So like, how do the teachers know that the kids mastered the material? Would they still have the same traditional test, or could you have a thing where a child finishes one video, they somehow demonstrate that they've absorbed what it taught, and then they go on to the next video, and so people kind of work at their own pace?
Yeah, and when I started the Khan Academy, it's most known for the videos, but there's an entire software piece that I started really building for my cousins, and now several tens of thousands of people are using the software. And the idea is you start everyone at 1+1. There's these little modules. People can log in right now and start working on it. Starts at 1+1 equals 2. And the paradigm isn't get 80% right and you're a C student, or 90% right, you're a B, or 95% and you're an A student. The paradigm is get 10 in a row. Because even if you're an A student and you got 95% right, what was that 5%? In math, I think we can all appreciate in mathematics, if you have even a 5% gap, when you build on top of that, you don't know what something is to the 0th power. Then when you see it in calculus, you're like, gee, I don't know, I was an A student, but I still didn't know that one special case. So the paradigm is get 10 in a row, and as you get 10 in a row, you get, and while you're doing the module, is tracking everything, every interaction with the actual software. So if you think about it, you're getting instruction from the video, you're getting practice and feedback directly from the software in real time, and then everything is being tracked. So it's actual real-time assessment that's actionable. The teachers can actually get data on what to do about what students, and everyone's working at their own pace.
Because the tradition is that everybody goes in lockstep, which is bad in two respects. One respect, the slow kids get left behind. The other respect is that the fast kids are held back.
And the real irony is sometimes there's a flipping of, I think we've had the experience where you're like, oh, this is easy, and you're kind of bored, and all of a sudden, wait, I missed that, and you've now fallen behind. And so, and I've seen it in the data of students using the software, is that sometimes a student will, when they're working at their own pace, a student that you might say is slow initially because they're spending more time on one concept, once they get that out of the way, they race forward. So it's actually very hard to predict who are the slow or the fast students. And so it's, and just going back to the traditional model, it's, on some level, we've gotten so used to it because it's 1,000 years old, but we don't question this idea of passively getting lectures, then you go home and you do things in a vacuum and you keep doing that process for several days, and then you get a snapshot assessment. And when you get the assessment, it tells you knew 80% of that concept. And now in the normal world, when you're learning something, if I only know to ride a bike 80% of the way, I'm going to keep sitting on that bike until I can always, before I try out a unicycle.
Yeah, and a lot of people seem to have a real math phobia. I've known people who just don't believe they can understand anything in math, and it might be because they missed one. Like it's a chain of knowledge, and if one link in the chain is broken, then you lose the rest of the chain. But here, you don't advance to the next link until you're sure that you've mastered this link.
Right. There's a couple of. I'm convinced that a lot of the frustration that goes on in, say, an algebra class isn't because the student is slow or because the teacher is bad. It's just that the student has a weakness in borrowing numbers or negative numbers, and there's no way in that algebra class to address that negative number. The student might not even know that they have that basic weakness in negative numbers, and they just keep talking past each other. So I think you're exactly right. That's the problem, is that no matter how good you do the traditional model, how good the actors are in it, if you have this basic core weakness, there's no way to address it in the traditional model.
Let me throw out a question that any of you can feel free to answer. Is learning itself an art? The usual model is that the child is a passive vessel in which you pour the knowledge. Is learning something that you have to know how to do, like you have to learn how to learn before you can even start?
The museum, the game program and your methodology really teaches us, and we learn it, that there's a different way of learning where you are the master of the speed, how fast you learn. You go forwards and backwards. It's your choice. So people who come to museums, they give random a chance. They run around. They discover their talents. So learning is not working in the future, I think, with a teacher outside and a lot of kids sitting there and just watching at this teacher. I think we want to be part of this learning process, and we want to really organize it ourselves. And I think in all of our 3 cases that's happening nowadays.
Well, yeah, that's the power of a video game. In a video game, the player is the star of that universe. It revolves around you. They're designed that way. And remember, human beings, as a species, we survived because we learned to learn. We are the learning species. We are programmed from birth to learn in an environment where it's important to learn.
And you get immediately feedback.
And you get immediate feedback. Just as with Sal's video game learning, it reverses everything. What does the teacher say? Go home tonight, your homework is to acquire the Sword of Doom. We build that game, so acquiring the Sword of Doom requires solving some math problems. The child probably won't solve the problems that night. So they go back in, the teacher says, go and look at Khan Academy and you'll find on video 35 exactly what you need to go back in tomorrow night and capture the Sword of Doom. The child now is motivated in a right environment, and they've got all the resources available. Teacher, textbooks, videos, brings it all together.
I think a lot of people who have made the greatest contributions in computer science didn't make it because of what they learned sitting in classrooms. It's what they did at home, playing and putting things together.
They dropped out. Many of them dropped out of school.
Yeah, and to your point about this learning to learn, and is there, I have a 15-month-old son, and he is a natural learner, just like what these guys are talking about. That's all he wants to do. In fact, if you take him away from exploring and playing with something and seeing and understanding, that's what upsets him. And I think the problem isn't that we need to teach people how to learn. I think a lot of our current institutions actually go in the opposite direction of our natural learning instincts. Even though you want to be active and engaged and explore things, they're treating you like a vessel that needs information to be poured in.
And here, go ahead.
In 1980, that's now 30 years ago, I learned Latin at a school. And I was not really good at Latin. So I bought one of the first laptops. I put all the vocabulary of this book into this little computer. And the computer was asking me the word, I typed it in, and when I typed it correctly in it, he erased it. If I made an error, he recorded it, and then he asked me the wrong ones again. Yeah. And I basically learned how to program BASIC at those days. My Latin didn't really improve, but
so instant feedback is really important. You don't pour knowledge into the vessel all year, and at the end of the year, you give a one-time test to see what they learned.
Yeah.
And then move on if they didn't.
Now, there are a lot of good methods to improve education, but for example, here in the state of California, education is a huge bureaucracy, and bureaucracies are highly resistant to change. Is there any way that some of the ideas we're talking about could actually find its way into this big, massive, inertial system.
Well, one thing I'm seeing just from letters from Khan Academy users, and I'm getting a couple of hundred every day now, is that some students are using Khan Academy as their primary instruction, and they're just showing up at their university or their high school just to kind of show what they've learned. And so I think it's hard to change the system. It's a big beast, and you got to kind of massage it slowly. But I think over time, when people find these alternate sources for learning their information, and professors start to say, wait, gee, people are just showing up. I'm just a test administrator. I'm not actually, they're learning someplace else. Hopefully, the system itself will say, gee, maybe we need to reflect. I don't understand why there are 300-person lecture rooms anymore. I mean, if you think about it, on-demand video is better in every single way. A 300-person lecture room is a complete broadcast, completely passive. On-demand video, you can pause, repeat, watch at your own time. But the inertia, the bureaucracy is continuing to do. I mean, even a 20-person classroom, you have to question, but 300-person, I can't, I've challenged everyone. No one can think of why this exists, but at every university, you pay $30,000 a year, they stick you in these rooms, and you get a broadcast lecture.
Well, I think we're in the middle of that really social change already, and it's happening, You prove it.
It's happening on the edges, but it can happen on the edges because one guy in a converted closet can reach 16 million people.
Yeah.
I mean, the technology allows small groups of people to make big change.
Well, the internet is really the backbone of the change because that is what enables the instant communication from anywhere to anyone at almost no cost. And we're always looking for new ways to apply this, and we're probably at the very beginning of figuring out, how to really apply it.
Yeah.
So now, what's your economic model for this? You give the product away for nothing.
It's mysterious, and it's I used to work in the hedge fund world. I was an analyst, and I was doing all of this part time, starting for my cousins really, and it started to take off. And in September, I just felt, and it's all for a not-for-profit basis. Khan Academy is a 501c3 organization, and we could talk about why I decided to do that. There was some temptation to go on a
People can donate without.
Yeah, they can donate, but then
deductions.
I'm limited to it.
Right.
But it was initially essentially self-funded, and there's some donations coming from the viewers, just spontaneous donations, and there's a little bit of advertising that's going to khanacademy.org. I wasn't taking a salary until very recently.
Unfortunately, I'm going to have to cut you off because I just got the signal that we're just about totally out of time.
Oh, okay.
So we're going to have to wrap the show. I'd like to thank my three very distinguished guests, Peter Fries, Keith Devlin, Salman Khan. Thanks to all of you for being here and advancing public knowledge on how to improve math training so we can continue to maintain this huge technological society we've created. Thank you for watching. Be sure to tune in next time. I'm Marty Wasserman. See you next time.